Alright, today we're talking about Chapter 7, Section 1, percents. So we're going to have a brief review of converting percentages, and we'll go and snip example 1 along with it. So the word percent comes from the Latin percentum, which means per hundred. So percent means hundredth. Thus, 72%, and I'm right here, the 72% is 72 over 100, and 0.72, they all have the same meaning. All three of these mean the exact same thing. Okay, so to change a decimal number to a percent, we're going to move the decimal point 2 places to the right and add a percent sign. And that's it. We just move, so to change a decimal to a percent, that's all we do. All right? To change a percent to a decimal, we're going to go the opposite way. We're going to move the decimal point 2 places to the left and drop the percent sign. Okay, so just basically just opposite operations there. To change a percent to a fraction, what we're going to do is we're going to write the percentage in hundredths form and reduce. So 30%, all right, so 30, it's always, if we're talking about percent, we're always going to put it over 100, and then we're going to reduce it, right, into its lowest form. And then to change a fraction to a percent, what we're going to do is we're going to write the fraction in decimal form and then change a decimal to a percent. So 1/4 in decimal form is 0.25, and then we're going to go up here, remember up here, to change decimal to a percent, we're going to move the decimal 2 places to the right and add a percent sign. So let's do A. So we're going to change 0.254 to a percent. So we have a 0.254. Well, if we're going to take this decimal and move it 2 places to the right and add a percent sign, let's do a different color than red. If we do this and add a percent sign, well, then we end up with 25.4%. And then B, we're going to change 76% to a decimal number. Well, then what we're, excuse me, what we're going to do is, again, do the opposite, right? So we're going to say 76%, okay, like this. All right. Well, there's a perceived decimal right there, right? And just numbers, they have perceived decimal there. You can write it, you cannot write it. You generally write it when you're talking about when there is a decimal point. But if there's not a decimal point, you don't write it. But there is an understood decimal point there. Okay. So what we're going to do is we're going to take that understood decimal point and move it to to the left right there. So this becomes 0.76. Okay, remember we drop the percent sign. So changing between percents and fractions. A, we change 12.5% to a fraction. So how do I change 12.5% to a fraction? Well, we know that 12.5% is simply 12.5%, right? Okay. Well, we said what we do is we change this to we put it over 100, right? So we're going to say 2.5 over 100. 100. All right. And if we want to get rid of the decimal form, then what we would do is we would multiply by 100. Okay. And we could do that, but well, let's go ahead and do that. Let's go ahead and get rid of the decimal point. Okay. So if we multiply by 100, I'm sorry, by 10. If we multiply by 10, so if we say times 10, then I'm not sure if that's the way. Yeah, we'll still go and do it. I'm hesitant here because one could just simply put 12.5 divided by 100 and know that 12.5 goes into 100 8 times. How do I know that? Well, 12.5 goes into 25 2 times, right? 2 times 12.5 is 25. Okay. And then 25 goes into 100 4 times. So 2 times 4 is equal to 8. Now, that might be a little confusing now that I write it out. So let's actually not do it that way. And let's do it the way I was going to originally do it, where I multiply by 10. So I'll multiply by 10 over 10 here. Well, 12.5 times 10 is equal to 125. And then 100 times 10 is equal to 1,000. And then from here, we can reduce this fraction, well, basically the same way, I guess, down to 1/8. Okay, because 125, I mean, you could say you could reduce it by, you could put 5 into it a lot, or you can say, okay, well, 125 goes into 125 one time, and 125 goes into 1,000 8 times. Basically, the same thing you could have said here. 12.5 goes into 12.5 one time, and 12.5 goes into 108 times. Okay. B, change 3/8 to a percent. Okay, so what we're going to do is we're going to do 3/8. So 3/8, if I were to put that into my calculator, it would be 0.375. And I want to change it to a percent, so I'm going to take this and go to the right 2 units and add a percent. So this means this would be 37.5%. Okay. So consider the statement, 15% of 80 is 12. This statement has three numbers in it. In general, solving a percent problem involves knowing 2 of these numbers and trying to find the third. That is, there are 3 basic types of percent problems. We can break down the sentence in the following way. I mean, yeah, I guess that's okay. So the sentence is 15% of 80 is 12. Okay, so let's take it back to red. So the takeaway here is mainly looking at this right here. Okay, the base equation is rate, okay, rate being the percentage, times the base, okay, so what percentage of what is equal to the amount. Okay, so 15% of 80 is 12. So again, rate is the percentage, the base is, you know, what am I taking the percentage of, and then the amount is as noted, right? So we're going to look at this formula here. Oh, I didn't erase a lot of that, did I? There we go. We're going to snip the formula. Let's see. We could, all right, since the textbook is giving you this formula to go about solving these percent problems, I'm gonna let the textbook have its preferred method. Okay, um, and what I'm gonna do is I'm going to for these next 2 examples. Let's see, 2. Yeah, we'll do maybe these next 3. Yeah, we'll do these next 3 examples. My particular way. Okay, so the textbook has theirs, and if you want to learn it that way, you're more than welcome to. But I think it's also fun learning different methods to go about solving problems. And, well, that's about it. Let's put 3 here. Oh, that's not what I needed. Okay. So again, like I said, we could do it by the way the textbook does it, and there's nothing wrong with the way the textbook does things. I just like I've just done things my way for a long time, and I want to do it this way again. Okay. So what we're going to do is we're going to um, no, honestly, hmm. No, okay. So I learned how to do this a long, long time ago. I was really big into sports when I was a kid, and I remember just like looking at like completion percentages of quarterbacks and stuff. And this is how I learned how to do it. It seems more intuitive to me. If I'm wanting to find a percent of a number, what I'm going to do is I'm going to multiply that number by the percent. Okay. If I'm wanting to find the number, I'm going to divide by the percent. All right. So here's what I mean. So I've got example 3 is saying reading what is 72% of 800. Okay. Well, what I'm going to do is I know 72%, I'm going to put it in decimal form. So I'm going to say 0.72, okay, times 800. Okay. This tells me 72% of 800. Okay. And if we do the arithmetic there, let's go ahead and do it. 800 times 0.72, it's 576. Okay, that's if I want to find the percent of some number. If I want to find the percent of some number, I'm going to multiply. Okay. Example 4 is worded slightly different, and you're going to have to be able to recognize this. Okay. So we're going to say, so it's saying 57% of what number is 163.191. So we're wanting to find what number 163.191 is 57% of. Okay, and I guess this goes back to our rate, base, and amount stuff. Okay, and again, you can learn it that way as well. All right, but since it's in a textbook, I'm going to go my way. So if I go back to example 3, just to reword again. Example 3, if I wanted to find the percent of a number, okay, I multiply. If I wanted to find the um, the actual number that I'm taking the percentage of, then I'm going to divide. So I'm going to do 163.191 divided by, and the same procedure, I'm going to take the 57%. Let's move this over to the left a little bit. I'm going to take the 57% and put it in decimal form, which is 0.57. Okay. And so if I do that, 161.191, I'm sorry, 163.191 divided by 0.57, that's 286.3. 286.3. And then example 5 is saying what percent of 180 is 45. Okay, this is just simply going to be the ratio. So if I was to put it back into my um, football card collection, Dan Marino completed 45 out of 180 passes, right? And 45 out of 180, well, you'd say 45 divided by 180, which is going to be 0.25. So let's do 45 divided by 180, which is going to be 0.25 or 25%. Okay, so well, I don't know if I should recap it because I feel like I can get kind of confusing, but you can hit the rewind button. If you want to do it this way and you want to try and memorize another formula, you're more than welcome to. But as I said, rewind it if you want to hear the exactly what I said before. I'm not going to repeat it again, but that's just how I've always done things. And well, here let's actually do this way because I remember also doing this. Um, example 4. Let's say that example 3 and example 4 I kind of get mixed up. Okay, I get mixed up. What do I divide by? What do I multiply by? Okay. Well, if I'm wanting to find what 72%, what is 72% of 800? Okay. Well, 72% of 800. If I accidentally, not accidentally, but like if I'm just playing around and I say 0.72 divided by 800, I get a very small number. I get 0.0009. And and that number is so small, it's not even close to 72% of 100. So you know it's wrong, right? Um, so that's another way to go about things, is to see if it makes sense, right? So familiarize yourself with, I guess, what I said, or go about it the way the textbook wants. Either way, that's how we do percentages. So let's do applications with percentages. So a bicycle was purchased at a discount of 25% of its original price of $1,600. What was the sell price? Okay, so if we bought a bike and it was discounted 25%, that means I bought the bike $1,600. That means I bought the bike times at 75% of its value, right? 25% discount means I'm paying 75%, right? And 75% in decimal form is 0.75, and that's it. That's 1,600 times 0.75, and 1,700 times 0.75 is equal to 1,200. Holy cow! What kind of bicycle is that? Um, I mean, I guess that's what I honestly don't know if that's how much bicycles cost, but that's one heck of a way. Okay, sales tax. So this reads, suppose a 6% sale tax was added to the sale price of $1,200. What was the total paid? What was the total paid for the bicycle? Okay, so um, if I wanted to add a 6% sales tax, right, which in Florida I think it's 7%, right? Or at least it is in Lake City. If I wanted to add 6%, what I'm going to do is I'm going to say, okay, so $1,200. Well, we could actually do this one of two ways. No, we'll do it this way. 6%. 6% sales tax here. What we're going to do is we're going to say 1,200 times. We're not going to say times 0.6, right? Because 0.6, that's 60%, right? It's going to be 0.06. Okay, and 1,200 times 0.06 is going to be 72. Okay, so I'm paying $72 in sales tax. So total, I'm paying $1,200 for the bicycle plus $72 in sales tax. So I'm paying $1,272 total for the bicycle. It's still extremely expensive bicycle. I mean, I mean, you get what you pay for, right? I don't know. All right, so next up, determining commission. So this has potential to be a brain teaser. So a saleswoman earns a salary of $1,200 a month plus commission of 8% on whatever she sells after she has sold $8,000 in furniture. What did she earn the month she sold $25,000 worth of furniture? Okay, so if she sold $25,000 worth of furniture, so a saleswoman earns a salary of $1,200 a month plus a commission of $8,000 on whatever she sells after she has sold $8,000 of furniture. So she only earns commission on furniture she sells over $8,000. Okay, so right away, if she sold $25,000 worth of furniture, the first 8,000 of it is not on commission. So 25,000 minus 8,000 is going to be 17,000. So she's only earning commission on $17,000. Okay, but she's earning 8% commission on it. So you'd say 17,000 times, again, 0.08, not 0.8, because 0.8 is 80%. So 0.08, and this is definitely a calculator moment. 17000 times 0.08, $1,360. So 1360. So she earned $1,360 in commission. Okay, so total, what does she earn? Okay, so for the entire month, she earns a base pay of $1,200. Okay, so $1,200 if she sells under $8,000 of furniture. Everything over $8,000 she gets commission on. Right? In this particular month, she got $1,360 of commission. So she ended up with 2560, $2,560 for the month. Not sure if the dollar sign should be there, but we're gonna put it there anyways. Okay. So next up we have percent interest. All right, so Akshi sells homemade greeting cards on the internet. Last year she sold 160 cards. This year she sold 176. What was her percent increase in sales from last year to this year? Okay, so if she sold 160 last year and 176 this year, then she sold 16 more. Okay, so she sold 16 more greeting cards this year than last year. Okay, well, if she sold 16 more, what you're going to do is you're going to say 16, and then you're going to say divided by 160. Okay, or you can write 16 over 160. Okay, and this is how you determine percent increase. You take the difference, and then you divide it by the original. Okay, so let's do another way here. So let's say we're going to do 176 minus 160 divided by 160. Okay, this is going to work every single time we talk about either percent increase or percent decrease. In this particular case, we increased. Okay, and what I wrote in the yellow is what happens in here, right? Because I mean 176 minus 160 is 16, and the 16 divided by 160. But this formula here is the way to go about it, okay? Well, 16 divided by 160 is going to be 10%, 0.1. But she increased her sales 10% for the year. Right? And percent decrease, so luckily we're going to have we can do the exact same thing we just did, except we're going to decrease. Okay, so we'll set it up just like the previous example, if it's able to. 3 years ago, you bought a new car for $25,000. Your business is doing well, and you are now looking for another new car and want to trade in your first car. The dealer has told you that the trade-in value of your car is now $14,500. What is the percent decrease in value of your car? Okay, so yeah, we set it up exactly the same. So we're going to say 14,500 is the new value, minus the old value of 25,000. Okay, and then divided by the original of 25,000. Okay, same procedure here. If you recall, so like this is the new value minus the old value divided by the old value. New value minus the old value divided by the old value. So same procedure there. Okay, so let's just do this all in one fell swoop here. So 14,500 minus 25,000 is going to be 10,500, and then negative 10,500, and then negative 10,500. So negative 10,500 divided by 25,000 is negative 42%. Okay, so negative 40. Let's do this. Let's actually put this in yellow. It's going to be equal to a negative 0.42. Okay, so we decreased in value 42%. So we can say minus 42%. We decreased in value 42%. That's how we do it. So example 9, example 10, they're set up pretty much the exact same way, whether you are increasing or decreasing your percent. So example 11, calculate the percent of profit for both A and B and tell which is the better investment. Okay, so $300 profit on an investment of $2,400. Okay, so a $300 investment, I'm sorry, $300 profit on $2,400 investment is equal to, well, that's 1/8, and 1/8 is 12.5%. So 12.5%. Again, just put that in the calculator. You'll get 0.125, and you can convert that to percentages as we saw at the beginning of this section. So you get 12.5%. And then B, 500. Well, that's easy. 500 divided by 1,000. Okay. Well, 500 divided by 1,000, you put that into your calculator. You should get 0.1, or in other words, 10%. Okay. So which one is the better investment? Obviously A, you get better return on your investment, 12.5% versus 10%. Right? And that concludes Chapter 7, Section 1.